All right, I mentioned that I'm going to share an interesting sorting algorithm, which is a little different from all the other algorithms that we have covered so far. So we saw that the best possible sorting algorithm that one can come up with has the complexity of n log n. But this sorting algorithm I wanted to surprise you with is called counting sort. And this has the complexity of order of n, or it's a linear algorithm. Now, one may think that if there is a linear algorithm, why care about these n log n algorithms? But the key point is that the counting sort works only when we know the range of the inputs is pre-decided. For example, we can say that the values of the keys can only be 0, 1, 2, and 3. So it is, so we can call it K, the total number of possible, so K possibilities for the keys. But the total number of entries, so number of entries can be much larger. It can be maybe 1,000 entries are there. But any given entry has to fit within these possibilities. So this is our n. So this complexity for counting sort is in fact order of n plus k, and that makes it a linear complexity algorithm. All right, so let's develop some insight with the help of an example. So suppose I have 8. So suppose there are 8 entries. So 0, 1, 2, 3, 4, 5, 6, 7. So the corresponding A of I, where we are storing the inputs, is, so 8 entries, they are all fitting within 0, 1, 2, and 3, this range. So you can say K equal to 4 here and N equal to 8. So what are the values here for the keys? So you have 1, 3, 1, 2, 3, 1, 0, 0. The first thing that we want to find out is the frequency, so count of each of the possible entries. So J essentially are the possible values of the key, so which is 0, 1, 2, and 3. So how many zeros are here? We have 2 zeros. So we have 2. How many ones are there? You have 3 ones. How many twos are there? You have only 1 2. And how many threes are there? We have 2 threes. So count, let's say count 1, which is the first value of count, just captures the frequency of each of these possible entries. Then the count 2 is capturing the cumulative frequency. So what we are going to do is that we are going to take any entry. So we start from 1 onwards, right? So 1 is going to be sum of, so count of I is equal to count. So let's store this in the same variable to be easier to demonstrate. So this is going to be count. So count of J is equal to count of J plus count of J minus 1. So it starts from, so J is going from 1 to K. Okay. So it's going to be, So count of j plus j minus count of j minus 1. So this stays 2 because we are starting from 1 onwards. So it's going to be 2 plus 3, 5. Then it's going to be 1 plus 5, 6. Then 6 plus 2, 8. So what we have done by doing this is that we have identified the starting positioning of each of these values which are going to be represented in the sorted order. So if you want to see how the sorted order would look like, it is basically 0, 0, then 1, 1, 1, then 2, then 3, 3, right? So if you see the positioning of these, right? The positioning of this is 0, 1, 2, 3, 4, 5, 6, 7. Okay, so you can see we are almost there because we know that the starting point for the first entry is going to be derived from the 2. So after these 2 zeros are placed, then the starting point is going to be, so 2, 3, 4. So you can see the starting index is matching this. Likewise, the starting index for 2 will be derived from this. So after you have gone through the positioning of all of these, then the positioning of this is directly derivable from here. So there's 5, and the positioning for the next one for 3 is derived from 6, and then you're done. So this is the basic idea for doing the counting sort. So essentially what this will do now, so if you have I is here, so you have I which is going from 0, 1, 2, 3, 4, 5, 6, 7, and you have A of I is essentially 1, 3, 1, 2, 3, 1, 0, 0. So then you can put count of A of I. So which is basically we are trying to figure out the frequency of each of these. So frequency of 1 is what? The frequency of 1 we can see, I mean not frequency, sorry, positioning of 1 is going to be 5 here. So we want to we can see that it's going to be actually the positioning of the 1 is actually 5 minus 1, right? So we have to kind of subtract 1 from it because of the 0 based indexing, because this is representing the 1 based order. So this is going to be the positioning of this 1. The positioning of this 1 is based on here. So this is going to be derived from 5. So which is, you have to do 5 minus 1. So we have to do count this minus 1. So which is going to be 4. The positioning of this is going to be 4. And we have to subtract, we have to decrement the count after that. So we have to say count of A of I minus minus. So with that, the count gets updated for 1. So now instead of 5, this becomes 4. After this got, after we have positioned this. So let's see if this is our sorted order. So this is our sorted array. And let's say 0, 1, 2, 3, 4, 5, 6, 7. So we are saying that I found out where I'm going to position this 1. I'm going to position this 1 here, right? Because it is count of this minus 1. So count of this was 5, minus 1 is 4. And we also adjusted the count to 4. Okay, so that the next one comes, it will be positioned here at the 3. Okay, so next, what is the next entry that comes? Next entry is 3. So where do we locate 3 here with respect to this? So 3 is here. So 3 is in the position number 8. So again, count of this is 8 of 3 is 8. So 8 minus 1, which is 7. So where am I going to position 3 here? It's going to go here. Okay. Next comes 2. Sorry, next comes 1 again. So 1 again we are locating. So 1, now we have updated the count. So again, the count of this gets updated. So if you have to track, this count got updated to 7. Okay. So 1 came again. So 1 we are locating again here. We found that the new count value is 4. So 4 minus 1, which is 3. So where do we position 1? We position here at the 3rd position. Okay. Next comes 2. So we again locate the positioning for 2. It is 6. Okay. So by the way, I forgot to update this to 3 with the count minus minus. So next comes 6. So 6 minus 1 is 5. So where am I going to place 2 here? At the 5th position. So 2 comes here, and this gets reduced to 5. Okay. Next in the list is 3. So again, we look up 3. When we look up, it's 7. 7 minus 1, it's 6. So where am I going to position? We're going to position 3 in the 6th position. Okay. And this got decremented to 6. Okay. Next comes 1 again. So 1, when we look up, the new value for the count for that is 3. 3 minus 1 is 2. So we place 1 in the 2nd position. Okay. And then the next value is 0. So we locate 0. 0, the positioning is, forgot to update this to, this will become 2 after positioning. So then the next one is 0. So we look up, it's 2. So that it's 2 minus 1, the 1st position. So the 0 gets placed here. And again, we look up, it is 0. So now 2 got decremented to 1. So it is, when we are looking up again 0, we find it's 1. So 1 minus 1, it is 0. So I position 0 here. And this is how the sorted array will come out. So overall algorithm, if I have to write down, so it is comprising of these steps. So initialize. So initialize count array. Okay. Then compute frequency, compute position. So frequency of each of these 0, 1, 2, 3 in A of I. Then you compute the position of each of these 0, 1, 2, 3 in the count. Compute the position and store in the count. So this updates the count. So update. So this stores in the count the frequency, and then it updates the count to reflect the positioning. And then the last step is to reflect the sorted order based on positions. So these are the 4 steps. So if you have to write down the algorithm, it would look like this. So first is the for j going from 0 to k. So 0 to k minus 1. because so we are storing 0, 1, 2, and 3 in this example. So we have, and we say count of j is equal to 0. So we initialize it just so that we can the count of each of these. So count of j. So this is initially they become 0. So this is our j. So this is the k-1 entry. This is the 0th entry. So after, so this is our initialize step. So this is our step number 1, step number 2, step number 3, step number 4. This is our first step. Second step is we are computing the frequency. So therefore this needs to run. So I running from 0 to the n-1, the full length of the array. So here we do, so here we are computing the frequency. So you want to do count of a of I plus plus. So this is going to adjust the frequency. Third step. So now we want to do the cumulative part. So this time it's going to run from j going from 1. So remember, so if you have to do this positioning, this has to go from 1 onwards. So it's going to run from 1 to k-1, and then we are going to say count of j equal to, or we can say plus equal to count of j-1. So now the positioning has been calculated. Now it's just the emission of the sorted order. So again we go, so I running from 0 to n-1. So it has to span the entire thing. So now we want to store in some sorted list. So let's say S is our sorted list. So S is going to be deriving its index based on the count, right? So we want to say count of A of I. So this part we saw, and then we have to do -1, right? We have to position it. So -1 equal to A of, we are placing the A of I. And then we subtract count of A of I minus. And that's about it. So this is going to produce this whole sorted order. So thank you very much. That's all we wanted to cover for today.